Proceed in Jacobian and we will take more examples. So now it's time to do case study. This is what we are doing. Okay, so it is time for case study. It is time for case study and this is what actually we have been doing, we are doing. Now we have example of a trapezoid or trapezoidal area. This is what example we are taking. Now as for the introduction, the any integral calculus. So we are in a phase to solve, integral calculus. Integral calculus. So any integral calculus has three reasons. One is called limit, one is called integrand, and one is called differential. Limit, integrand, and differential. So there are three parts. There are three parts in the integral calculus. So now where we need Jacobian, what is the story of the Jacobian? Jacobian is a term that is used while manipulating the integral side. Limit of the integration, integrand, differential. There are three parts in the calculus. Like if I say I have a region, that is a circular region, and then I have to integrate sine x square plus y square dx dy. I have integration, I have integrand as a circular region, and then sine x square plus y square, sine x square plus y square, and dxy plane, dx dy. Now the limit is circular region of any radius, and then integrand is sine x square plus y square, dx dy. That is the situation. Now what is integrand? Sine x square plus y square. Sine x square plus y square is the integrand. And dx dy is the differential. And limit is circular region. What it is in real sense? What it is in real sense? So in real sense, it is like, okay, this is x-axis and this is y-axis. This is z-axis. Now this is xy plane. This is xy plane. This is x-axis. This is y-axis and this is z-axis. Now, if I say I have sine x square plus y square, sine in braces x square plus y square bracket close, and then dx dy, dxy plane. Integral limit is circular region. What it is? Many times we have kind of reiterated it. What it is? Now, if that is the case, sine x square plus y square, it is called integrand. Sine x square plus y square is also called fxy, function over x comma y, function over small f braces x comma y braces close fxy, that is sine x square plus y square. If that is the scenario, sine x square plus y square and then dx dy, integrand is sine x square plus y square. That is z value. That is z value, z equal to fxy. So height is, now if I take any point x comma y, if I take any point x comma y, consider it is 3 comma 4. If that is the case, then I'll apply it to a function, Python function. Function takes x comma y, function takes x comma y and returns a z value. So function takes 3 and 4 and it does some manipulation over it and finally it computes a numeric value and returns it. That numeric value is fxy. If x and y is fed to a function, then it will return a value, that is fxy. F is a function name. F is a function name. Xy is its parameters. So it returns a numeric value, that is z. Z equal to fxy. Fxy, whatever it computes, that becomes z. That becomes the height. So at every point x comma y, every point x comma y, there will be a unique height, unique point height. Okay. If I connect all those points, then it will make some shape, that is called surface. Okay, so if this is the surface and this is xy plane, altogether it makes three dimensions, where the height is called, that is z value, it is called dependent component, and xy plane is called independent component. Xy plane, not x-axis, y-axis. Then xy plane is dependent upon, or xy plane constitute x-axis and y-axis. If this is the scenario, if this is the scenario, then what is sine x square plus y square? Anyone can now imagine what is sine x square plus y square. If x, y is 0 at the origin, the value is 0. But if someone go along x-axis where y is 0, then it will rise like a sinusoidal wave. Then at pi by 2 it become maximum, and then it will come down. Similarly in y, along y-axis, it will rise like a sinusoidal, and then it will come down to 0 at pi value, and then it will go negative, and like that. Same as minus x, same as minus y, same as any point in the xy plane. So it is something like a fountain, means from the where water is coming out, from there is no water, and then water is coming like this, or lotus. Okay, it is like a flower, it is like this. So this is the, it is very nice if someone can draw a surface graph of any 3D. Now if this is the scenario, then what is the volume? What is integration circular? This is what exactly in the book people find. What is the, if there is a integrand is sine x square, integrand is sine x square plus y square, dx dy, integration over a circular region with radius 2, radius 2 or radius a, whatever it is, what is the integration? People jump and quickly the method of substitution here. First you draw, what it is. What are you trying to do? You are trying to calculate a volume, of a surface. The surface is 0 when x and y is 0, height is 0, and it flows like this all around, the origin. Okay, if that is the scenario, then what is the volume of this surface when I take the region in xy? What is the volume of the surface? Anyone would ask, what is the volume of the surface? Volume of the surface is infinite. I don't know, because if I go along xy axis, everywhere we have value for the z. Okay, I think a better I would say in other words, z equal to, this is the better way, z equal to sine x square plus y square, sine x square plus y square, when x square, plus y square less than equal to 2. When x square plus y square is less than equal to 2. Otherwise, beyond that it is 0. Now from the center, this flower goes like this, whatever. When it becomes 2, beyond that it is flat at the xy plane. Nothing is there. So volume is that much only. So we are confining the xy value to be in a limit of a circle. This is the limit. Means I am the surface what we have computed through sine x square plus y square, that surface is mapped on xy plane, and it has x comma y everywhere. This x comma y we take in xy plane must be confined in a circle, not go beyond it. If you go beyond it, then z value is 0, means volume is 0, only up to there only. If that is the case, then calculate the volume of sine x square plus y square along dxy plane. This is also called surface integral. Along dxy plane. By default, it is dxy plane only. but it can be along any plane. This is the equation sin x square plus y square. Can you calculate the integration along this plane, along this plane, along this plane, along this plane? Okay. Now I want along xy plane. So if you want along this plane, this plane, this plane, this plane, then this sin x square plus y square has to be in vector notation. And then the plane along which we want, that will have again vector notation. Then it will come as dot product. This is typically called surface integral. This is typically called surface integral. Now, if it calls surface integral, now we are calculating surface integral along xy plane. Surface integral along xy plane. This is what we are trying to do. Now we will use method of substitution and x square plus y square. X square plus y square, this form generally typically it motivates someone to use polar coordinate. Then do the substitution. Now dxy plane is dxy by d theta r into d theta r. Dxy plane by d theta r is the Jacobian. Means the xy plane, if I have a circular region as limit, then x equal to r cos theta, y equal to r sin theta would map it in theta r plane as a rectangle. This is what we want. The limit region should not be non-rectangular. It should be rectangular. Because if it is rectangular, then x and y will have numeric limit. Numeric limit means they are independent to each other. Otherwise, in circular fashion, typically y will be minus a square root of a square minus x square to a square root of a square minus x square. X will be minus a to a. But y is dependent upon x. They should be independent to each other. They should be rectangular. How to make it rectangular? Someone has to apply its brain. Y equal to a square root of a square minus x square. X square plus y square equal to a square. Now what I should apply in the method of substitution in x and y, so that x square plus y square should become one variable. Right now there are two variables, x and y. These explanation would not be available anywhere else. This is something that is diamond. Means how to take method of substitution. In method of substitution, what variable I should, what parameterization I should take. X equal to what, y is equal to what. Our aim should be that limit, whatever the limit is, should be, instead of non-rectangle, it should be rectangular. Please support us. +91 is India country code 94831606110. 94831606110. +91 is India country code. Now, aim of any method of substitution, because sin x square plus y square dx dy, people would find very difficult in calculating the integration. Now idea is, what should I take x equal to and y equal to, so that my life would be easy. In that fashion, first generally people see the integrand, then they see differential, then they see the region, limit region. First see the limit region. Now limit region, if limit region is rectangular, then nothing to worry. Then see the integrand and then see the differential, see the integrand. Then at the end, tackle the integrand. Now the limit is non-rectangular. In that fashion, we have to tackle it. Now y is square root of a square minus x square. X square plus y square equal to a square. Now here in the limit, two independent components are there, whereas in the limit there should be one independent component. There are two. Can apply something that it will become one, possible. If x equal to r cos theta and y equal to r sin theta, then it becomes r square. Only one independent component is there, r. That's it. Equal to a square, r equal to plus minus a. Okay. So plus minus a. Then it is something like that, one of them I can keep. So r equal to a. Here minus a, or I can start from 0, making half of the calculation. Then latter half we will calculate separately, whatever it is. Now can you see how meticulously I changed two independent variable limit to one independent variable limit. That is the idea. Now we will come, this example we have already solved. Now we will come to our actual example, that is trapezoidal. Okay, so we are calculating trapezoidal. In trapezoidal, we have x-axis and we have y-axis. X-axis, y-axis. Now there is a line x plus y equal to 1. There is another parallel line x plus y equal to 3. Why I am saying parallel is x plus y equal to 1, then dy by dx equal to minus 1. dy by dx equal to minus 1. X plus y equal to 3, dy by dx equal to minus 1 again. So they are parallel to each other in vector form. So x plus y equal to 1, x plus y equal to 3, x-axis, y-axis. In that fashion, then there is a reason between this and x-axis and y-axis. This is trapezoid. Okay, this is x-axis, this is y-axis, this is x-axis, this is y-axis. Now this is x plus y equal to 1, this is x plus y equal to 3. Now both these parallel lines, they go and cut x-axis, these parallel lines go and cut y-axis. Whatever region is coming in between, trapezoid region, that is the limit. That is the limit. Now it is x minus y whole square. Integrand is x minus y whole square. Okay. And then e to the power x plus y dx dy. Now can I take x equal to r cos theta and y equal to r sin theta? What is the aim? This trapezoid should convert into a rectangle. If not, then tends to rectangle. That is the concept. Okay. Now, what is the problem here? There are big problems. Now, limit is x equal to 0, that is y-axis. Another limit is y equal to 0, that is x-axis. Another limit is x plus y equal to 1 or y equal to 1 minus x. Another limit is x plus y equal to 3, y equal to 3 minus x. Four limits are there for a for one area. If for area, there should be two limits only, x from here to here, y from here to here. Now, someone should make it limit of 2 at least, then we'll think about rectangular region. Means it is very, very kind of a maze kind of solution. It is very cryptic, very tedious. X equal to 0, y equal to 0, y equal to x 1 minus x, y equal to 3 minus x. This is the reason. If this is the reason, then x minus y whole square e to the power x plus y dxy plane or dx dy. This integration we have to calculate now. Mind blowing, mind thrilling, head hitting in the wall. How someone can solve it? Now x plus y equal to 1, x plus y equal to 3. This is one limit. Okay. Now it looks like x plus y, there are two independent components. Can I make x plus y equal to u? If someone can find in trigonometry, I have seen people, they find this kind of solution also in trigonometry. Tell it to them and someone can propose here. So x plus y equal to 1, then u equal to 1. X plus y equal to 3 means u equal to 3. Simple, right? U equal to 1, u equal to 3. Now x equal to u equal to x plus y equal to u. X plus y equal to u equal to 1 to 3. Simple, right? Now we have x equal to 0 and y equal to 0. X equal to 0 and y equal to 0. Okay, this proves that I have to take another independent variable. Not only u will work, v. So we have in the integrand x plus minus y whole square e to the power x plus y. It hints us to try another independent variable as v equal to x minus y. Let's try, but we have to try in the limit only. X minus y equal to v. Now x equal to 0. If x equal to 0, then If x equal to 0, x minus y equal to v. If x equal to 0, then v equal to minus y. X plus y equal to x minus y equal to v. Then v equal to minus y. X plus x minus y. X plus y equal to u. If x equal to 0, then u equal to y. If I replace there, then v equal to minus u. V equal to minus u, that is x equal to 0. Now y equal to 0 is the another line. Now we'll try again. X minus y equal to v. Then x equal to v, y equal to 0. X plus y equal to u. Then u, okay. Then u equal to, one is x equal to v, one is x equal to u. Means v equal to u. Means v will go minus u to u. V will go minus u to u, minus u to u, and u will go 1 to 3. Now at least 4 limit I change it to 2, and it is all right. If it is go, it is dependent. V is dependent upon u. It is not numerical, but at least it is monomial. It is not x square the way earlier it was y equal to square root of a square minus x square. First of all, it is binomial, means it is polynomial, and then a square root, then minus. It was kind of tedious line. It comes to a circular region. Now it is straightforward. Now v equal to u, v equal to u, dv by du equal to 1. So now limit is, if I take uv plane, this is u and this is v. U is 1 to 3. 1 to 3. 1 v is equal to u, means v is a line 45 degree like this, and v equal to minus u. Then another line is like this, minus 45 degree. This is the reason I have to calculate. So it is a pure triangular region, but still triangular region. It is not rectangular. This is what we expected, but still it is far better than x equal to 0, y equal to 0, and x plus y equal to 1, x plus y equal to 3. Now v equal to minus u to u. So v equal to u, v equal to u, if this is u axis and this is v axis, if this is the origin, v equal to u means this line. And I'm sorry, this line, and v equal to minus u from origin, it is this line. So one is this line and one is this line. And then we have u equal to 1 and 3. Draw a perpendicular line from here and here, and up region above the x and down region. This region will be the region to calculate. Still, one of them, one u is numeric. This is what we could achieve, and v is now kind of numeric. If someone can try, he can try other substitution also. No one has bound. As I have said, people try in trigonometry here also. But this is not perfect solution. This is what I am saying. Perfect solution would be, u should be some numeric to numeric, v should be some numeric to numeric. This is what is the perfect solution that anyone would suggest. But this is what we could get now. So u is 1 to 3 and v is minus u to plus u. Now we have x minus y whole square, e exponential e to the power x plus y, dxy plane. Dxy plane can be written as dxy by duv into duv, du dv, dxy by duv means, if I have in xy plane I have a trapezoidal, and in uv plane we have some kind of a double triangle. So double triangle, I could say, I don't know what is this shape is called. If this is one side, other side is like this, this and this. This is a simple kind of quadruple. So that is a kind of a quadrilateral, whatever it is. Now, but big thing is, one is numeric. U is 1 to 3. That is big help here. Okay, so if that is the scenario, If that is the a kind of scenario, then we can now try calculating. So if I have xy plane, there it is trapezoid. Why trapezoid is complex? Can anyone think about it? Why it is complex? If I have x-axis and I have y-axis, then one line is like this, x plus y equal to 1. One line is x plus y equal to 3. The lower limit is a flat parallel to xy, x-axis. Upper limit should also be parallel to x-axis. Then it was easy. If upper limit is also parallel to x-axis, lower limit also parallel to x-axis, then y I can set 0 to that, and then x I would settle. 1 should be at least constant, but it is not the case. 1 is x equal to 0, 1 is y equal to 0. It should be y equal to 0 to y equal to 3, and then x equal to in term of y. That is also all right. That is the problem. If one limit is x-axis, then other limit should also be parallel to x-axis. But that is not the case. One limit is x-axis, other limit is y-axis, and that two slant height. So this become a tripod. It is complex. It is really complex. Now here it is easy. One is a straight line, means x u equal to 1 and 3 means there are two vertical lines. At least two vertical side of, if rectangle has four vertical lines, then two vertical line we got it at the end. And then one is like, if this is 1 and this is 3, from origin one is like this, cutting this two perpendicular line like this, and one is cutting this perpendicular line this, u equal to b equal to minus u. Then what is the reason in between, that I have to calculate. But at least two side of this quadrilateral, two side is perpendicular. Only this side and this side is slant. If someone makes one side is again straight line, either parallel to x-axis or y-axis, then three sides will be perpendicular. Then it will be very lines. But anyway, 50% we have got. Now x minus y whole square, that is u square, v square e to the power u. Now dxy plane by duv plane. If this is xy plane and trapezoidal is there, on uv plane there is a quadrilateral. If I make unit change in the area in UV plane, whatever the shape we have quadrilateral, if I make unit change, one unit change in that, then how many unit change it bring in the trapezoid in xy plane? Dxy plane by duv into duv. duv is du dv, dxy by duv we have seen tons of time. Now it is d position vector on xy plane by duv. If position vector is p, dp by du cross dp by dv. So dp is xi plus yj, dxi plus yj by du cross dxi plus yj by dv. So now it will come as Jacobian and it will come as dx by du. In the matrix, it will come as a matrix formation. Dx by top row is dx by du, dx by dv, and bottom row is dy by du, dy by dv. Now u equal to x plus y, v equal to x minus y. Then x equal to u plus v by 2, and y equal to x, u equal to x plus y and v equal to x minus y. Then y equal to u minus v by 2, u minus v by 2. So x equal to u plus v by 2 and x equal to u plus v by 2 and y equal to u minus v by 2. So dx by du, dx by du, dx by du is 1 by 2, dx by dv, dx by d is minus 1 by 2, and here whatever. Now this will come as a numeric value, so nothing to worry much. Numeric value, something that I can keep outside, and then du dv. Now here it is v square exponential to the power u, v square exponential to the power u. Now first we will integrate with the v, because v in the limit it is in term of u. It should not be the case. We say that the net aim should be to bring it in a rectangular fashion. If that is the case, whatever it is, now we can integrate it, and e to the power u I can keep outside v square, that is v to the power 3 by 3. V to the power 3 by 3. If that is the case, then v to the power 3 by 3, 1 by 3 I can keep outside again. V to the power 3 limit is minus u to u. So u, if I keep, then u to the power 3 minus minus plus u to the power 3 again 2u to the power 3, that I can keep outside 2. Now u to the power 3. U to the power 3. Now u to the power 3 e to the power u. This I have to integrate now. We can go with the, now the limit is now constant. So now it is easy. Now someone can go with the integration by part. U to the power 3 e to the power u. Try with the u to the power 3 integration of u to the power u, e to the power u only, minus then integration sign and then differentiation of u to the power 3, that is 3 u square u e to the power u. Again try it, u square e to the power u minus 2u. So finally it will break down, and at the end it will come as e to the power u. Full thing, now settle it, u is 1 to 3. It is highly, very easily solvable. Now think that someone cannot do at all. X equal to 0, y equal to 0, x plus y equal to 1, x plus y equal to 3. So Jacobian and parameterization and method of substitution makes sense only when someone tackles the limit reason. We will take another example as parallelogram. We had taken trapezoidal. Someone can try any parallelogram where one side should be constant and other side should be variable, the way we did x plus y equal to 1 x and something like that, and then x plus y dx dy, x plus y dx dy, and there is a parallelogram. Someone can try vertical side, the one side is, two sides are parallel to x axis and other two sides are slant line, or one side is parallel to y axis and two axis and other two sides are slant line, or some, this is what someone can try. Otherwise, if I say x axis and y, it will become trapezoidal. So this is what someone can try. Don't mind supporting us, it helps us. +91 is India country code, 9483160610 is the telephone number. 9483160610 +91 is the India country code.